All right, another video on linear relations. This one is on perpendicular lines. You must be excited. All right, so when we talk about perpendicular lines, what we've learned in the past is that this means the lines cross at a right angle or a 90-degree angle. And that's all well and good, but in this course, what we need to know is that perpendicular lines are related by their slopes. Now, just like parallel lines, those slopes have a relationship, but unlike parallel lines, their slopes aren't the same. Now, remember, parallel lines cross through the graph at the same steepness or the same slope. They ran side by side and never touched. Perpendicular lines are different. Their slopes are related by something called negative reciprocals. Now, negative reciprocals are two big nerdy words to explain a pretty simple concept. Here's how their slopes are related. If you have the slope of one of the lines, you've got to take that slope and make sure it's in fraction form. If it's not in fraction form, whatever the number is, you can put it over +1 to turn it into a fraction. So don't worry if you're given a slope that's not a fraction, just put it over 1 and then follow these steps. All you got to do once that slope that you're given is in fraction form, if it wasn't already, you flip that fraction, meaning the top number goes down to the bottom and the bottom number comes up to the top. And once you've flipped the fraction, you change the sign of that fraction. Changing the sign means that if the original fraction was negative, it comes out positive in the end. But if that original value was positive, then you've got a negative once you do the negative reciprocal. So changing the sign means changing the original value from positive to negative or from negative to positive. Now, for some reason, it can be a little bit confusing identifying a negative fraction to begin with. So if you're given a fraction and the negative sign is either out front, up on the top number, or down with the bottom number, then you've got a negative value for that fraction. So as long as there's only one negative sign, doesn't matter where it is, out front, up top, on bottom, that's a negative fraction. Now be careful, it's possible, although rare, that you might have a negative value on top and on bottom of your fraction. If you see two negatives in a fraction, one on top and one on bottom, that actually represents a positive value. Remember, a fraction represents division, and when you have a negative number divided by another negative number, the result is always positive. Now, keeping in mind that slope is the a value in y equals ax plus b, see if you can follow along as I show you how to find the slope of a line that's perpendicular to the one represented by the equation on the screen. Now notice when I start out here, I wasn't given the proper format for this equation. It wasn't in y equals ax plus b form. So I have a little bit of work to do here before I can actually get started. And now that the equation's in the proper format, all I have to do to find the slope of a line that's perpendicular to this one is grab that a value, turn it into a fraction, and find the negative reciprocal. So first up, I'm going to take that a value and put it over 1 to turn it into a fraction. And remember, no matter what number I'm turning into a fraction, I always put it over +1. Doesn't matter if the number up top is starting out negative. To make anything a fraction, it's over +1. Now all I'm going to do is flip that fraction, so the bottom number is coming up top and that top number is going on the bottom, and I'm going to change the sign. Now my original fraction was negative, so watch how the answer is positive here. And that's what we mean when we say change the sign. This was starting out as a negative, so it's got to be positive in my answer for negative reciprocal. If it was starting out positive, it would be coming negative in the negative reciprocal. Now that you get the idea of what negative reciprocals are in perpendicular lines, watch these couple of examples on how they might ask this on an exam.
Hey guys, we just watched a video on perpendicular lines, and so we're going to take a look at our first question for perpendicular lines, which says what is the equation of a line perpendicular to another line whose equation looks like 8x minus 100y is equal to -50, and that perpendicular line passes through 200, 4. Before we get started, just a couple of very quick reminders. NRS, negative reciprocal slopes. The second we start dealing with perpendicular lines, we're talking about the perpendicular line having a slope which is the negative reciprocal of the other line. So that's the whole flip it and change the sign thing, and we'll do that in order to get the slope of the line that's perpendicular. I just want to give you a quick reminder visually what perpendicular lines would look like, right? So if 1 was this one right here, I'll put it in dash just so you can see it, then the negative reciprocal slope would look something like that, where it crosses at 90 degrees. And so basically by knowing the slope of this one, we can get the slope of the other one, although it will not be the same slope like it was in parallel lines. It will be that negative reciprocal. So we're going to work the equation, but before we do anything, once again, we're sitting here with an equation that's not currently in y is equal to ax plus b, so we'll do that first. I'll write down the equation. 8x minus 100y is equal to negative 50. So there's our starting equation, and this is the one that's going to be perpendicular to the one that we're trying to find, which will pass through that point over there. And I'll subtract 8x from both sides over here. That's going to leave me with negative 100y is equal to negative 8x minus 50, and then I'm going to divide everything by negative 100. When I do that, I'm going to get y is equal to positive 0.08x plus 0.5. So negative 8 divided by negative 100 gave me positive 0.08. Don't forget your x. And negative 50 divided by 100, positive 0.05. So this is the equation of the line that we know. And when we're looking for the line that's perpendicular to this one, passing through this point. Now we know that this point has both an x and a y, and we know we're looking for an equation over here of y is equal to ax plus b. So we know that we need the b in order to get that equation down here, and we need the a. And we have an x and a y that we can substitute in if we need to. So to get that b, since we have an x and a y, if we had an a, y ax substituted would let me get that b. I don't have an a. And if the lines were parallel, I would. If they were parallel lines, I'd say, hey, sure, they got the same a, 0.08. But that's not the case. What I have is a slope over here for this line. A is equal to 0.08. But I need to get the negative reciprocal of that slope in order to get the slope of this line over here. This line over here is the line which is perpendicular to this line over here. So how do I change that? How do I get that into a negative reciprocal? There's that whole flip it and change the sign thing. Well, how do you flip a decimal? I mean, it's a decimal. There's nothing to flip. You might say there's no fraction here. Well, there is a fraction here, and what we're going to remember is that that's over 1. Anytime you have a decimal or any kind of a number, a whole number that doesn't have a fraction, you can make it into a fraction by putting it over 1. It doesn't change the value on the top when you divide something by 1, and now it looks fractional. So I have to flip it, and then I have to change the sign. Since it was originally a positive number, we know that at the end, our new a, or our perpendicular a, has to be a negative number. Has to be, because this starting one is a positive number. So I'm going to flip that, and that will become, right, so a over 1 will become negative 1 over a. Flip it and change the sign. So really, that just means negative 1 divided by 0.08. And that will be my new slope. Negative 1 divided by 0.08. And that's going to be equal to sorry, I have a little light issue here, negative 12.5. So a couple of ways of thinking about it. This is if you use a little formula where that negative is always on the 1. That's always going to cause the sign change. If you don't like the formula, you can kind of go to common sense, right? If you just flip that 0.08 divided by, 1 divided by 0.08, there's your 12.5, which is a positive number. You can see it's a positive number, and because the original slope was a positive in negative reciprocal slope, we've done the reciprocal by flipping it, but you have to take that negative. So the positive became a negative. So whether you use the formula or you just remember to flip it and change the sign, either way, you're going to get that perpendicular slope. And now we just have to plug it in with the point that we know to get our b. So y, which is 4, is equal to a, which we now know is negative 12.5. That is the negative reciprocal of the 0.08 for the line that we knew, times x, which is 200, plus b. So I'm going to simplify this part right here. Negative 12.5 times 200 is equal to 2,500, which I'm going to have to subtract from b. So it's going to be 4 is equal to negative 2,500 plus b. So add 2,500 to both sides, and I'm going to get b is equal to 2,504. So for this equation, y is equal to negative 12.5x plus 2,504. Not the prettiest equation, but it's got a negative reciprocal slope to the 0.08, and it passes through 204. Hey, so we're looking here at perpendicular lines. This is number 2 for the practice here. Line 1 and line 2 are perpendicular, and what is the equation of line 2? So we know they're perpendicular because we've used the word perpendicular, but I'll take a second to point out that even if I didn't use the word perpendicular, I have the symbol here, 90 degrees, which tells me that these two lines are at right angles and therefore perpendicular to each other. So we're looking for the equation of line 2. There's line 2, and if we had 2 points in line 2, then we could just go ahead and do what we've done before, right? Use the 2 points, get the slope, calculate the initial value, and we'd be done. But we don't have 2 points in line 2. We only have 1 point in line 2, and that means we don't have enough information, at least just yet, to solve the equation of line 2. The equation of line 2 is going to require y is equal to ax plus b. And we know we have an x and a y. We've got negative 20 and 30. Negative 20 and 30 are in that equation, xy, xy. We need a b. We don't have an a, and we don't have a b. No way of getting that b, and at least from the line itself, no way of getting the a, so we would seem to be stuck. But because we know the equation of this line, and because we know that this line is perpendicular, we can use this line right now that's hiding underneath my pencil to get its slope. And once I have the slope of line 1, I can take the negative reciprocal of it, since they're perpendicular, and that will give me my a on equation 2. So I can cheat to get my a because it's perpendicular to the line where I have 2 points, right? So where I can get a slope, I can use that to get that slope. So let's get the slope of line 1 first. Let's get the a of line 1. And the a of line 1 is really easy. It's going to be y2 minus y1 over x2 minus x1. So I'll call this x1 and y1. And I'll call this x2 and y2. So I'm going to use the 2 points on line 1 to calculate the slope of line 1. A is equal to 26 minus negative 10. Watch that double negative there. Over 18 minus 0. 26 minus negative 10 is 36. And 18 minus 0 is 18. 36 minus 18 is 2. So the slope of line 1 has an a of 2. Now why do I care? What's the point, as I said, of getting the slope of line 1? Really only one reason, and that's because we're going to use it to get the slope of line 2. And the reason we can do that is because we know the slope of line 2 is the negative reciprocal of line 1. So we're going to take to get A, so we're looking here for the perpendicular A, we're going to get the negative reciprocal slope of 2, right, of that 2. And the way to do that, right, we're going to flip it. So we're going to make it first into a fraction. We're going to flip it and change the sign. So really easy. It's going to become 1 over 2 when I flip it, and because it's originally a positive, my new perpendicular A will be equal to negative 0.5. 1 divided by 2, and then changed into a negative. So once that's done, we can now substitute the point that we want into the equation really easily. Y, which is the 30, and oh, I should mention this. Now that we're going to get the equation of this line right here, sometimes the mistake that students make is they get that negative reciprocal A, and then they try to use one of these 2 points to get the equation of line 2. Well, to get the equation of line 2, once we have that slope, we have to use the point that's in line 2, right? You can never get the equation of line 2 using a point from line 1. We're just using line 1 to get the slope, and then that point goes in the substitution. So y, 30, is equal to A, negative 0.5, our negative reciprocal of 2, times the x, which we know is negative 20, plus b, right, as always. And so we're going to simplify this part right here. I get 30 is equal to negative 0.5 times negative 20 is positive 10. I'm going to subtract 10 from both sides now, and I'm going to be left with 20 is my b. So the last step is to put everything together and write it down in the bottom where the solution gets written. So it's going to be y is equal to A, negative 0.5 x plus 20. And that's the equation of line number 2, which is perpendicular to line number 1. This is perpendicular to question number 3 with a bit of a mix in there, because we're going to be asking you about parallels, or neither parallels nor perpendiculars. Are the following equations parallel, perpendicular, or neither? And then justify your answer. Well, quick reminder, if they're parallel, they'll have the same A. And if they're parallel, same A. Perpendicular have negative reciprocal slopes, or perpendicular A's, if that's the sign for perpendicular. And neither parallel nor perpendicular means they just have different A's, but not negative reciprocals. So regardless of which of the 3 instances is going to occur here, we can't do anything until we get these equations isolated. And so to isolate the y in this equation, I'm going to start by subtracting 6. And let's bring that over there. This guy over here, sorry. And that's going to give me 4x minus 3y is equal to negative 6. And then I'm going to subtract 4x from there and there. And remember, you're subtracting 4x, not just 4. Right, goes away, and that leaves me with negative 3y is equal to negative 4x minus 6. The 4 and the 6 have nothing to do with each other. These are not like terms. They have to stay like that. Last I'm going to do is divide both sides by negative 3 right across the board there. And that'll leave me with y is equal to, now negative 4 divided by negative 3, calculator time here. What you're going to notice is you're going to get a repeating decimal. So that's positive 1.3 with the 3 repeating. It's very important that you indicate that repeating 3. And if it was like a super long decimal, like 0.12575 or something, you want to keep as much of that decimal as possible. It's going to affect our calculations later. Plus 2, because negative 6 divided by negative 3 is a positive 2. So there's my first y equals ax plus b. Over here, a little easier. I only have a little bit of work to do. I just have to divide everything by 8. And that's going to leave me with y is equal to negative 6 divided by 8 is going to be equal to negative 0.75 x plus 2 again. So we can see right away that the lines are definitely not parallel. I mean, this slope, this A over here and this A over here are not at all the same. The A here is 1.3 repeating, and the A here is negative 0.75. So I can scratch out parallel. There's no way that these lines are parallel. So the question is, are these numbers negative reciprocals of each other? And if they're negative reciprocals of each other, then these would be perpendicular lines. If they're not negative reciprocals of each other, and they're not the same, then that tells us these lines are neither parallel nor perpendicular. They're just two differently sloped lines that cross somewhere. So how do I do that? Well, I have to take the negative reciprocal of this A right here. And when I take the negative reciprocal of 1.3 repeating, if I get this number, then this tells me that the lines are perpendicular. So we'll see what happens. I'm going to get that perpendicular A by saying, okay, take your original A, and that's going to change into negative 1 over A, right? So change the sign and flip the fraction. So on your calculator, what we're going to do is we're going to go 1 divided by 1.3 repeating. Negative 1, sorry, divided by 1.3 repeating. So negative 1 divided by 1 point, and now this is important. You want to put as many of those 3's in there as you can. And that's going to come to negative 0.75. So my perpendicular A is equal to negative 0.75. And you could see that it's the same now. So when I took the negative reciprocal of 1.3, so, put it over 1, flip it, and change the sign, that creates the negative 0.75. They're the same. They are the negative reciprocals of each other, negative reciprocal slopes. So these are perpendicular lines. They have negative reciprocal slopes. And that's really all you have to do to determine whether two lines are perpendicular or not. Just one last thing I'd like to show you. What happens if you don't put that whole 3 repeating in there? And this is really important. So if on your calculator you just went 1, so this is kind of how to make a mistake over here. If you take that 1.3 and you just leave it like that without the repeating part over the top, and then you put that over 1 and you take the negative reciprocal, so that's going to change into negative 1 over 1.3. Well, watch what happens. Negative 1 divided by 1.3, we no longer get 0.75. You get this close to 0.75, but not the same. And that might be enough to throw you to think that they're not negative reciprocals. It's very important when you have that repeating decimal that you put it in there to give yourself the right answer.